In this section, we'll talk about advanced techniques, optimizations, and other tooling you'll encounter in the real world. In this video, we'll look at a rendering optimization with the lazy component. Before we look at the lazy component, I'm going to make sure you understand what it does. First, we need to know what memoization actually is. Memoization is a technique for storing the output of a function for a given set of inputs. Memoization only works when a function is referentially transparent. This means that the function does not influence or get influenced by outside sources. An outside source may be things like using math.random or relying on a global variable. The best use case for memoization in JavaScript is for functions that do long-running computations. Memoization is only effective when the effort of getting the stored output is less than the effort of running the calculation. For instance, functions that track all inputs and resulting outputs can become memory consumption hogs. The lazy component solves this by only remembering the last inputs and output. The lazy component is a special VDOM node with first-class support in Hyperapp. The component props become your inputs, and the resulting virtual DOM tree becomes the output. Without lazy, every component prop change, Hyperapp rebuilds that component's virtual DOM tree, even if it's deep or expensive. With lazy, the resulting virtual DOM tree is stored and reused as long as the props do not change. To use lazy, you must provide a view prop which tells Hyperapp how to build the virtual DOM tree of your component. The view, and all other props passed to the lazy component, are forwarded to your view function. When any prop changes, including the view prop, Hyperapp discards the previous stored output and recalculates the virtual DOM tree of that component. In Hypernews, a list of stories can have upwards of 500 entries. Without lazy, if any of these stories updates, it will re-render all the stories. With lazy and some well-thought-out props, only stories with changes will render. Let's see the current re-renders in the Hypernews feed for new. To do this, let's add a random background color to each story. This function will generate a valid and random background color. Here it is being used in the story data component. Let's see what it looks like. Notice how the background color of each story changes, sometimes rapidly. Ideally, most of these stories shouldn't be re-rendering. Lazy component to the rescue! Here's an implementation of the lazy component. Since story accepts regular arguments, I created the story component wrapper, which accepts a props object. Let's update our stories component to use lazy story. And now we can observe a much more stable set of UI updates. Keep in mind that every 10 seconds, we're updating the current time, which will re-render all of the stories. Let's recap what we learned. First, the lazy component memoizes the last results of its view prop function. Second, lazy isn't just a component, it's a special type of virtual DOM node built right into Hyperapp's core. Third, lazy is great for expensive components, which can be in collections that render often or perform many complex live calculations that are referentially transparent.